We're trying to explore a very hard problem. Can we create a rover that uses virtually no power because all the power we use comes from the environment? So here's the big picture. This is the rover, we're calling it. As it appears here, it looks like an eel. It's a bio-inspired, soft-robotic rover. Essentially, this is a rover with electrodynamic power scavenging, which means it has a tether. So the concept is this: an electromagnetic tether scavenges power from Europa's passage through Jupiter's magnetosphere. It's the relative motion of Jupiter and the moon, Europa, which then induces a current on this tether. We use that electrodynamic tether power to split water molecules into hydrogen and oxygen components. That combustible gas is then directed into a plenum, where it's detonated, and that process produces a shape change in the soft body of this rover. So it's this detonation inside the body that changes the shape and causes it to sort of move its body through the water. The body itself is made out of some kind of silicone or some other kind of polyacrylamide, some other kind of squishy rubbery stuff, and that allows its shape to change in ways that we don't normally see if we're thinking of robotic systems. It turns out that nature is very good at making efficient creatures that swim through the water. Can we learn from nature? Can we create a rover that swims not through high-speed screws or propellers, but instead through very slow motions of its body, and thereby transferring as much as possible the energy that we do have available into locomotion? So that's the name of the game here. So the squid-like propulsion we're after here has been studied before, and we're replicating that by using a 3D printed mold. We create the silicone objects, pull them out of the mold. We have this well-formed silicone shape. At the moment, this doesn't look much like a squid, but it's getting there. And here's the video showing flash. That's the detonation. And then in this case, this three-legged device, kind of imagine the three legs of a maybe multiple-legged jellyfish. Those change shape so quickly that this thing jumps off the table and goes up about a yard in the air. So there's a lot of energy that we can store, and that gets expressed in kinetic energy of this body. So we got more work to do, but we're getting there. It's a little bit of a difficult problem, but that's why we think it's NIAC worthy, and we're very pleased to receive the support from NIAC for looking into this.